You're standing on a beach that hasn't been named yet, wrapped in a hide against a wind that refuses to warm up. The sky has looked like a dirty screen for months. Ash sits on everything. On your shoulders, in your food, in the water you drink. Behind you, a fire someone worked on all morning is dying anyway. The wood won't stop being damp. Your stomach has that hollow feeling that never fully goes away lately. Sleep hasn't come easy either, not with the cold creeping in at night. You glance at the horizon out of habit. It's the way you check your phone during a meeting that's going nowhere, half expecting something to change. Nothing does. 74,000 years ago, something in Indonesia detonated hard enough to dim the sun worldwide. So why aren't you dead yet? This isn't really a volcano story. It's a survival story with a body count nobody agrees on. Some researchers think this single event nearly wiped out our entire species. They estimate a number small enough to fit in a modern high school gym. Others think that idea is wildly overblown. Both camps have been arguing about it for almost 30 years, and neither one has fully backed down. Either way, the people who actually lived through it left clues in the dirt. Those clues are the only real evidence anyone has. Everything else is a guess. And those clues completely rewrite what surviving an apocalypse looked like. Honestly, they make the ancient version of adapt or die look a lot more impressive than the modern one, where the biggest crisis most of us face is a dead phone battery. Let's talk about the volcano itself. Around 74,000 years ago, on the island of Sumatra, Mount Toba erupted. This wasn't a normal eruption. Geologists rank it a magnitude 8 on the Volcanic Explosivity Index, the top of the entire scale. It's estimated to have blasted out roughly 1,000 times more material than Krakatoa's infamous 1883 explosion. That's still the eruption most people picture when they hear the word catastrophic. Toba blew a hole so large that the crater filled with rainwater and became a lake. Today, that lake, Lake Toba, is the largest volcanic lake on Earth. It's big enough to hold an entire island inside it. The ash didn't stay local. It rained down across South Asia, the Arabian Peninsula, and East Africa. In places, the layers are still thick enough to dig through today, thousands of miles from the source. Sulfur gas from the eruption reached the upper atmosphere. Researchers have found traces of it preserved in ice cores drilled in Greenland and Antarctica, opposite ends of the planet. That confirms just how far the fallout actually traveled. For scale, think about Mount Tambora, also in Indonesia, which erupted in 1815. That single eruption was violent enough to trigger what's now called the year without a summer. It brought failed crops, snow in June, and food shortages across parts of Europe and North America. Toba is estimated to have released something like 100 times more material than Tambora did. So whatever Tambora did to the planet for a year or two, Toba was capable of doing at a scale most of us can't really picture. And possibly for a lot longer than a single season. Here's where it gets genuinely useful. Scientifically, that ash acts like a global stopwatch. Wherever researchers find it, in a cave in India, a bluff in South Africa, a riverbank in Ethiopia, they know almost exactly when it landed there, within roughly a month. That's absurdly precise for anything this old. Most ancient dating comes with centuries of wiggle room attached, sometimes worse. Toba's ash gives you a single season instead. That's exactly what lets scientists eventually compare sites on opposite sides of the globe, almost like reading the same page of the same book. Getting that precision took decades of work. Researchers spent years refining radiometric dating techniques and analyzing the ash's exact chemical fingerprint. Essentially, they built a global lookup table. A speck of glass found in a lake bed in East Africa could be matched, with confidence, to the same speck buried in a cave on another continent entirely. Without that painstaking groundwork, none of the evidence coming up next would even be comparable. In 1998, researcher Stanley Ambrose proposed something dramatic. He argued the eruption triggered a volcanic winter, years of sharply cooler global temperatures. He said this environmental collapse crushed the human population down to a tiny handful of survivors. Some versions of the theory suggested as few as 1,000 to 10,000 breeding pairs worldwide, clinging on in isolated pockets. One eruption, one bottleneck. Almost the end of us, genetically speaking. For years, this idea more or less became the accepted story. It got repeated in documentaries, in textbooks, even in theories explaining why humans today have relatively low genetic diversity compared to other primates. Now here's the complication nobody mentions in the dramatic version. That bottleneck story has a problem. The evidence doesn't actually back it up. And it's not just one shaky data point undermining it. It's basically every major line of evidence researchers have checked since. Start with the climate itself. Toba was massive, no argument there. But when scientists went looking for a global temperature crash to match the theory, they kept coming up short. A 2013 study analyzed ash preserved in the sediment of Lake Malawi in East Africa. It found no sign of the catastrophic cooling the volcanic winter theory demanded. At least, not there. One of humanity's most important ancestral homelands may have barely noticed the eruption happened at all. Then there's the genetics, which is really where this theory should live or die. If a population truly crashes to a few thousand individuals, it should leave a specific fingerprint in modern DNA. There should be a sudden, sharp narrowing of genetic diversity right around that exact moment, the same way a traffic jam leaves a very specific pattern of brake lights behind it. Researchers have looked hard for that fingerprint. It's just not convincingly there. The population changes geneticists do see in deep human ancestry show up on a different timeline than Toba. They look gradual, spread across tens of thousands of years. Not one catastrophic crash concentrated in a single bad decade. Think about what that actually means. Decades of increasingly powerful genome sequencing, and still no clean signature of a crash at 74,000 years ago. If the near extinction really happened the way the original theory describes, that's exactly the kind of thing modern genetics should have nailed down by now. Instead, the timeline keeps refusing to line up. And it's not only humans. Other archaic human lineages, Neanderthals in Europe and Denisovans in Asia, kept going for tens of thousands of years after Toba erupted. They seemed genuinely unbothered by an event that was supposedly ending the world. If a global volcanic winter had been severe enough to nearly erase modern humans, you'd expect it to have hit our close cousins too. It doesn't look like it did. So if the sky went dark and the climate barely flinched, and the genetics don't line up, what actually happened to the people standing in the ash? Turns out, the best way to answer that is to stop modeling the disaster on a computer. Go looking for the people themselves instead. Not simulations, not projections, actual tools, left in actual dirt on the exact week the ash fell over their camp. The first site that cracks this case wide open sits about 4,000 miles from Toba, in southern India. In 2007, a research team led by archaeologist Michael Petraglia, then at the University of Cambridge, published findings from a site called Jwalapuram in what's now Andhra Pradesh. The location sits inside the Jereru River Valley. It's blanketed by a thick, unmistakable layer of Toba ash, easily visible even to the untrained eye. In places, that ash bed runs more than a meter deep, a solid gray wall marking the exact moment the sky fell. Here's what makes it remarkable. The team found stone tools both above and below that ash layer, made from the same local quartzite limestone and chert. This wasn't scattered evidence from unrelated cultures separated by centuries. It was the same core technology, the same style of toolmaking, on both sides of the eruption. Sharp flakes retouched into scrapers, blades shaped for cutting. Whoever made those tools was there before Toba blew, and they were still there afterward. They were doing essentially the same thing in essentially the same place, using a skill set passed down the way you'd pass down a family recipe. Petraglia put it bluntly at the time. Whoever occupied that site, he said, seems to have persisted straight through the eruption. Not fled, not vanished. Persisted, That single word does a lot of damage to the extinction-level version of this story. Later excavations at nearby localities backed this up even further. One nearby site turned up evidence of continuous toolmaking that stretched on for roughly 35,000 years after the ash settled. It's an unbroken sequence, with no gap where a shattered population should have been. That's not proof everyone everywhere sailed through Toba untouched, but it is proof that at least one group didn't just survive the eruption. They barely changed their routine. But here's the question that should be sitting in the back of your mind right now. Ash, from one eruption, fell in precisely dated layers across the entire globe. Could researchers use that same ash as a universal clock, anywhere they happen to find it? Turns out, yes. And that clock eventually led them to the exact opposite end of the human range at the time. The southern tip of South Africa. At a site called Pinnacle Point near Mossel Bay, archaeologist Curtis Marion and his team had spent years studying a cave system. Early modern humans had used it, on and off, for more than 100,000 years, and the team painstakingly mapped every artifact's exact position before it ever left the ground. Long before Toba, this same stretch of coast had already served as a refuge during earlier hard stretches of climate. That happened roughly 195 to 130,000 years ago, and again from about 74 to 60,000 years ago. In 2018, Marian's team published a study in the journal Nature with a genuinely startling headline. Humans thrived in South Africa through the Toba eruption. Here's how they proved it. Under a microscope, researchers found a single near-invisible shard of volcanic glass buried in the site's sediment. Its chemical signature matched Toba precisely. It also matched ash found as far away as Malaysia and Lake Malawi, over 4,000 miles apart. That let them pin the exact moment of the eruption inside the archaeological layers at Pinnacle Point, down to a matter of weeks. It lined up perfectly against everything the excavation team had already dug up around it. And what they found just above that ash layer wasn't decline. It was intensification. Signs of tool use and site occupation appeared to increase after the eruption, not collapse. Marian's explanation comes down to diet. The people at Pinnacle Point were eating heavily from the coast, shellfish especially, timed carefully to the rhythm of the tides. Think of it like timing a grocery run around a store's opening hours, harvesting mussels and whelks from the rocks right at low tide. Shellfish are dense in protein and nutrients. And unlike a herd of antelope or a field of wild grain, they don't really care whether the sky is gray for a few years. The ocean itself may have acted like a buffer, smoothing out temperature swings that were hammering the land nearby. While inland ecosystems may genuinely have struggled after Toba, this one coastal group had, more or less by accident, found a back door around the entire disaster. So we've got two groups now who didn't just survive Toba. They barely blinked. But the most convincing sight of all didn't surface until 2024. It might be the closest thing to a smoking gun this entire mystery has. The site is called Shinfa Matema 1, tucked into the lowlands of northwestern Ethiopia, along a tributary of the Blue Nile. Excavations there ran for more than 2 decades, led by paleoanthropologist John Kappelman of the University of Texas at Austin. He worked alongside a huge international team that included Curtis Marion, the same researcher behind the South Africa discovery. In March 2024, the team published their full results in Nature. This site had something the other two didn't, an almost month-by-month record of exactly how people adapted, in something close to real time. Dozens of researchers, from geologists to isotope chemists to stone tool specialists, spent years cross-checking every piece of that record against every other piece. That's part of why it took so long to publish. Before Toba, the people at Shinfa Matema mostly hunted land animals, antelope, warthogs, monkeys, with cut marks on bone confirming exactly what ended up on the menu. After the eruption, the local climate turned sharply more arid for a stretch of time. Rivers that once flowed steadily shrank into scattered, shrinking water holes. Researchers confirmed this shift using oxygen isotopes locked inside fossil teeth and ostrich eggshell. essentially a chemical weather record written into bone. And the humans there responded by completely changing what they ate. Fish, trapped in ever shallower pools as the dry season dragged on, suddenly became the easiest meal around. So that's what they hunted, in huge numbers, with evidence of cooking fires included. Here's the detail that actually made headlines, though. Among the stone artifacts at the site, researchers identified small, symmetrical, triangular points dated to right around the time of the eruption. Their shape and size suggest these are projectile points, most likely arrowheads. At roughly 74,000 years old, they're considered some of the earliest solid evidence of archery ever found anywhere on Earth. They beat out similar finds elsewhere in Africa by a few thousand years. Let that sink in for a second. In the middle of what's supposedly one of the worst environmental disasters in human history, a group of people didn't just endure. They may have invented an entirely new hunting technology to exploit the exact conditions the eruption created around them. Kappelman summed it up simply. Hunter-gatherers, he said, are good economists. When one food source dries up, literally, they pivot to whatever's actually available. Sometimes they build a brand new tool to get it. There's an even bigger implication buried in this one. Most models of how humans eventually left Africa for good assume it happened during lush, wet periods, when food was abundant along the way. The Shinfa Matema evidence suggests something almost the opposite. Seasonal rivers, shrinking down to a chain of waterholes during the dry months, may have worked like natural rest stops. They could have guided people and animals along a predictable path even in harsh, arid conditions. Researchers have started calling these seasonal routes blue highways. If that idea holds up, it changes the bigger picture. The same adaptability that got people through Toba may have also helped power the migration that eventually put humans on every continent on Earth. So here's the mechanism that ties all three sites together. It's not a miracle refuge, and it's not one lucky cave. It's flexibility. Jualapuram shows continuity, a tradition tough enough to shrug off a global catastrophe without missing a beat. Pinnacle Point shows a fallback food source, the coast, that barely registered the disaster at all. Shinfa Matema shows outright innovation under pressure, a brand new tool built out of pure necessity. 3 continents, 3 completely different responses, one shared underlying trait, the ability to completely rework how you get food the moment your environment stops cooperating. Researchers increasingly describe this as behavioral flexibility. Some now argue it's less about any single magic refuge, and more about a species-wide habit of improvising under pressure, wherever pressure happened to show up. It's not that any one group got lucky and found the one safe cave on the planet. It's that the species itself had already developed the toolkit for reinventing its own survival strategy on short notice, and that toolkit traveled with people wherever they went. It's worth being honest here too. This isn't a fully settled debate. Some regions genuinely may have suffered more than others, and the record from a handful of sites can't speak for every human group alive at the time. There are still gaps in the fossil and archaeological record big enough to hide a lot of hardship inside. Absence of evidence for collapse somewhere isn't automatically evidence that nothing bad happened there. But the pattern researchers keep finding, again and again, wherever they've actually looked closely, is resilience, not extinction. 3 independent teams, 3 continents, 3 completely different lines of evidence, all pointing the same direction. Toba didn't really test humanity's location. It tested humanity's adaptability. And wherever that adaptability showed up, whether it was shellfish, continuity of craft, or a brand new bow, people made it through. In at least one case, they may have come out the other side with a genuinely useful new invention. That doesn't mean Toba was harmless. Local disruption clearly happened. Diets changed. Rivers dried up. Entire landscapes disappeared under feet of gray dust for years at a time. Somewhere out there, groups will probably never find any trace of likely did struggle, or worse. But the old idea of a single near-extinction event, with a scattered handful of survivors huddled together in one magic spot on Earth, just doesn't match what's actually buried in the ground. The real story is messier, spread across 3 continents instead of one hidden refuge. And honestly, it's a lot more impressive. If you had to survive a year with no real summer, what's the first food you'd switch to? Drop it in the comments. We're genuinely curious how many of you would go full Shinfa Matema on it and start eating a lot more fish. Every single person alive today is technically descended from people who lived through this. Every argument you've ever had over dinner traces back to them. So does every meal you've ever taken completely for granted, and every convenience app on your phone that shows up the second you're mildly hungry. All of it runs through generations that once watched the sky stay gray for years and just figured it out anyway. No emergency alerts, no stockpiled supplies, just attention, memory, and a willingness to try something new when the old plan stopped working. You're not that different from them, honestly. Just better fed, with a slightly more reliable weather forecast, and a lot less practice going hungry. Picture that same ancient beach again. The wind still hasn't warmed up. The ash hasn't fully settled. The sky is still that same dull, dirty gray it's been for months. But this time, someone's cooking fish over a fire that finally caught. For the first time in a long time, nobody's stomach feels quite so hollow. They adapted. So did you.